Chapter 2 notes, data analysis, and units of measurement. All right, so what I'd like you to do with your note packets, I want you to fill out as we're going through the PowerPoint. This is a recording, so feel free to stop or fast forward me as you need. Some of you may need more time, some of you may need more of a review. So as long as your note packets are complete, you'll be set for tests and quizzes because you'll get all the content that you need. So this first slide are units of measurement. The SI units are next to the measurements that we're going to be very familiar with as we go through chemistry. So SI unit stands for International Standard. International meaning that they're used in most parts of the world so that scientists can communicate with one another about scientific data without any kind of confusion. So for time, it's seconds, length, meters, mass, kilograms. Amount of a substance you probably have not heard about is called a mole. We do have an individual unit on mole, so we're going to cover that topic when we get to it. And then temperature is in Kelvin. All right, so we're not going to convert from Celsius to Fahrenheit or Fahrenheit to Celsius just because all of our thermometers in our lab are in Celsius. So we will, though, have to convert from Celsius to Kelvin or Kelvin to Celsius, especially when we get to our gas unit. But just to give you a little information, the Kelvin cycle, it starts at absolute zero and is based on energy movement. And what energy movement means, it's the movement of molecules. So as I said above, Kelvin is the SI unit for scientific temperature measurements. And you'll find that Kelvin is used in many branches of science. And we're often going to have to convert to Kelvin or vice versa. Those are the formulas. I have them boxed, so please make sure you write them down. In here, you'll see that I always ask you to, if there's a formula that you have to memorize, I will always ask you to use that when you solve problems. I know this is super simple, and we're going to get to the point where we just plug this into our calculator without even writing down the formula. But for now, since we're starting off, I'd like you just to get comfortable with writing down the formula and then plugging in the number and then solving and then boxing your answer. So I always like to say that the topic sentence is equivalent, like topic sentence in English for a paper is equivalent to the formula in chemistry. Okay, so always, always, always write down your formulas. I will tell you, though, when we get so familiar and comfortable with this particular formula that you will not have to write it down because, that's just a simple basic step that you'll have to be doing. Okay, so here is the formula. So what I said is that you have to go ahead and write down your formula. So we can use Kelvin is equal to degrees Celsius plus 273.15. Notice that Kelvin does not have degrees, only Celsius does. And notice this number here, 273.15, you will see it written, if you look it up, as 273. You'll see it written as 273.2, and you'll also see it written as 273.15. We will talk about that when we get to sig figs, okay? So for now, 273.15, we'll just remember it like that. And depending on what number we actually use will depend on the number of sig figs. And that's coming up soon. All right, so we've got, okay. So now all we do, so that's your topic sentence, right? Your formula, and then you plug in the value. Plug it in. So we got 62 degrees Celsius plus 273.15. Simple, plug it into your calculator. Scientific calculators are a priority, a must in here. And you plug that in and you get 335.15. If there is a hardship with a calculator, please let me know so that I can help you, get past that hurdle. 335.15 Kelvin, sorry. Always box your answer. All right, so we can use that other formula right over here, the degrees Celsius, but I think it's just easier to have one that you've got down. I mean, all you did was rearrange that, but you know, regardless, however you like to solve it is fine, as long as you write your topic sentence. I'm just going to go ahead and reuse the same one. And then, of course, plug in the value. So this time we have Kelvin. And then we can subtract both sides, 273.15, so that we isolate degrees Celsius. Okay, plug that into your calculator, right? 45 minus 273.5 is equal to negative 228.15 degrees Celsius, and then, of course, box your answer. So you can see here on this formula, especially this formula right here, okay, so you can see that we can have negative degrees for Celsius, but the Kelvin scale only goes down to 0. So 0 Kelvin is known as the absolute zero. And that is the coldest temperature possible. And therefore that means that no molecules are moving. And you can see by that formula, the lowest possible degrees Celsius temperature is negative 273.15, as you can see that. So if you put 0 in for Kelvin, that would be negative 273.15. All right. So scientific notation, this is, you know, an algebra concept. You probably learned it in middle school too. So if this is good for you, you know, just fill out your notes and you don't have to, you know, watch me do the calculations. But if this is helpful, then by all means, go through it. It will help you on a test or quiz. So always make sure, you know, you got this stuff down. I know that this is a pretty simple concept, but it's been a while. Some of you are in Algebra 2 or Geometry. And, you know, I'm not sure how your spring semester was. So I'm just going to be pretty thorough in these notes, but please feel free to fast forward me. All right. As long as you fill in your notes, though, okay? So you can't, you know, you have to have complete notes. All right, so I'm sure you're all familiar that scientific notation is a way of expressing really big or small numbers, and it's used for scientific calculations. So you can use them for very large and very small numbers. And of course, it's much easier, right, to plug in all of these zeros here. That would be a big pain, right? So you'll also notice that every single number is always going to have a unit, because otherwise the numbers have no meaning. So every number has to have a unit, okay, or something. You know, there's 30 trillion cells, right? So here's my unit. Also, okay, so this is a really large number. This is the estimate of the number of cells in a human body. So to put this in scientific notation, because that would be a pain to put that entire number into the calculator. So you just simply, and you have to get your calculator on scientific notation. So there is, every single scientific calculator has that function. So you just have to find it. If you need help, you can ask me during office hours, but all of them are different. My Texas Instruments 30X, all I have to do is press the second key and then the key right next to it, which is DRG, but in blue it says scientific engineering. You click on that or press that, and then you scroll to scientific, enter, and then all your numbers will be entered in scientific notation. Okay, so that's 6, 7, 8, 9, 10, 11, 12, 13. So writing this is 3 times 10 to the 13. Notice this is greater than 1. This big old number obviously is greater than 1. It's a positive exponent. And of course, write your units. Okay, here is a super small number. This is actually an oxygen molecule, the mass of 1 oxygen molecule. Okay, so super, super small numbers, and this is what we're dealing with in chemistry. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. You can see, I mean, that would be a nightmare to plug that into your calculator. So our answer, now this is less than 1. It is not less than 0. This is a very, very small number, but greater than 0. So our answer is going to have a negative exponent, 2.66 times 10 to the negative 23rd grams. Okay, so any numbers that are less than 1, you're going to have a negative exponent when you put it into scientific notation, and any numbers greater than 1 will be a positive exponent. And always box your answers. All right, moving on. Okay, so this is kind of like, describing what it consists of. And we see that, of course, this is going to be our coefficient n, right? And then the exponent is a power of 10. All right, so on your calculators, you'll see that some of you, most calculators will have that key. It looks like that. When you use that, though, you do have to type in times 10 and then that key and then whatever the exponent is. If you want to use your EE key, you do not need to type times 10 raised to the power. You don't have to type that in. So all you have to do is type in your coefficient and then the EE and then whatever your exponent is. Okay? So there's a couple ways to plug this into your calculator. Just be comfortable with your calculator. So again, if you need any help on that, please reach out to me. Okay, so we've got, so place a decimal point so that there is 1. So that's important, 1 non-zero digit to the left of the decimal place. And I'll show you what that looks like. And then, of course, count the number of decimal places. And this will be the exponent on the 10. Okay, again, this is what I was saying earlier. If the original number was less than 1, okay, it's not less than 0. It's less than 1, because otherwise it would be a negative number, right? So, but if it's less than 1, the exponent is negative. Greater than 1, the exponent is positive. Okay, so here's some example problems. I've already done these for you, and I think they're, you just have to write the answers in your notes, but make sure you truly understand it. 289,800,000, that's a nice big number, much easier to plug it in to your calculator in scientific notation. So we've got 1, 2, 3, 4, 5, 6, 7, 8 places, which is why it's 2.898 times 10 to the 8th. Notice this is 1 non-zero digit to the left of the decimal. That's the correct way to write it in scientific notation. Okay, next problem is really small number. It is less than 1. So we're going to have a negative exponent. So again, moving your decimal place, 1, 2, 3, 4, 5. Oops, sorry. Brain fart. Okay, so 1 digit to the left of the decimal place, 1 non-zero number, sorry. So we've got 1, 2, 3, 4. So we've got 5.67 less than 1 is times 10 to the negative 4. Again, your numbers, they don't have any meaning unless there's a unit. Okay, so remember that. I do grade off if you forget your units, a half a point for everything. Okay, moving on. This is your practice. I'm just going to simply fill in the answers because I'm assuming that all of you, this is pretty simple. If it's not, that's okay too. I will work with you in our office hours. Okay, so I'm just going to simply write down the answers. And at this point, don't worry about these zeros right here because we will be talking about that when we talk about our sig figs, okay? Again, your units though, box your answer. Okay, so you guys should be able to do these on your own without looking at the answers. You're just double checking your answers with mine. Okay. Okay, so now to change scientific notation to standard form, okay, so simply move the decimal point to the right for positive, to the left for negative. You will be putting in your zeros to fill in the places. All right, so example number 1. Okay, so we've got 5.093 times 10 to the 6th. So simply it's 10 places. So 1, 2, 3, 4, 5, 6. Okay, so fill them in with zeros. Okay, and simply write out your answer. So 5,093,000 miles is your answer. Okay. Here we've got a number less than 1, so it's a super small number. And we're going to go the opposite way. We're going to go the left because it is a negative exponent. Okay, so it's a negative exponent. We go to the left. It's less than 1. 1, 2, 3, 4. So you do need to remember your decimal place on this one. So fill it in with zeros. So we've got 0.0001976 milliliters. Okay, again, you'll have example problems and practice problems. The practice problems are meant for you to do while in class. So while you're listening to me, it's a good idea just to pause and just to make sure that you can answer these on your own, just to make sure you're, where you should be. Okay, so here we've got a negative exponent. I'm not going to really go through this. If you need help, again, refer to our office hour link. I'm going to write down these answers because they're just the practice ones. We've already talked about how to do them. Positive exponents goes to the right. It's greater than 1. Oh, goodness gracious. I forgot my units on the second one. So please don't do what I just did. Because that would be a half a point. And that's just silly, right? To lose a point right there. Or a half a point on just units. I refer to those like silly, careless points as points on the table. So don't leave any points on the table. Because those are like the brain farts. Okay, so we've got... Okay, so now we're going to be solving problems using scientific notation. So this is kind of review from your algebra. You may have forgotten. I know it's been a while. But if you multiply and divide, there are different rules. So if it's multiplication, you're going to add your exponents. Okay, so you add. And if it's dividing, you subtract the exponents. Okay, now for the most part, you're just going to plug these into your calculator. So it's not really imperative that you know how to do this, but it is helpful in case you forget your calculator, or if you you're having problems punching it in and the answer doesn't make sense to you. So you want to do it by hand and make sure that it's correct. So I'm going to show you just this one time how to add and subtract and multiply and divide. I will not do this again, just because this is an algebraic skill, so you should have that down by the time you get to my class. But you know what? We're all learning, so I'm going to help you out in this instance the first time. All right, so let's say I don't have a calculator, okay? So we're going to just do this all by hand. So you notice that this is, oopsies, I hope I have enough time. Okay, so you'll notice that this is multiplication. So when it's multiplication, you're going to add your exponents. Okay, so you're going to add your exponents because it's multiplication. So minus 2 plus a minus 3 is times 10 to the negative 5. Okay, so those are my exponents added together. Okay, and then I'm going to multiply my coefficient 2.8 times 8.0. So I'm just going to do this longhand just this one time. Well, on these slides, times 8.0. All right, so multiply that out. Haven't done this probably in a while. One, 2. Okay, so that's our number, 22.40. All right, so notice this. We've got 22.40 times 10 to the negative 5, your units. Centimeter times centimeter is centimeter squared. Okay? Now, there's 2 non-zero numbers to the left of the decimal, so that's not correctly written in scientific notation. The rule is that there's only 1 number, so we must move this decimal place to the left. Okay? So when we do that, then we have to move the exponent as well. So I find that students find it easier when I say that if we're moving the 22.40 and we're going to make this smaller, right, into 2.240, so this is smaller, we make this exponent larger. Okay, and by making it larger, okay, this is a negative, it's going to be 10 raised to the negative 4. Okay, so that's smaller. Okay, so now we've written it correctly in scientific notation. We've got our units, and we're going to box our answer. Okay, now that's doing it by hand. Now, fortunately for us, we do so many calculations in here, you are allowed to have a calculator. And I will not ever say that you can't do anything without a calculator, okay? So let's just plug that into our calculators. All right, so, okay, so this is kind of an upgraded calculator, but I didn't pay for it, so you will see the advertisements. I'm sorry, but we're not going to use this that very often, so I'm not going to upgrade at this point unless I feel a need. Okay, so we're going to plug this in. Notice that I don't have that key with the arrow, but I do have the EE key, so that's what I'm going to use. Okay, so everyone's calculators are a little different, so you have to become familiar with it. That's the hardest thing on this. Okay, so we got 2.8. Okay, so times 10 raised to the power of is the same thing as EE, and then I'm going to put my negative exponent. Be careful. Make sure you use the right key for the negative. It's not the negative as in subtraction, okay? So make sure you look at your calculator well, and now we got our exponent. Okay, and then it's times, we got 8.0, the EE key, and then my exponent negative 3 equals. Okay, so my this version does not have scientific notation on it, so I can't put it in scientific notation with the calculator, but I simply can move my decimal, right? So 1, 2, 3, 4, oops, which is 2.24 times 10 to the negative 4. And that is what we have for our answer. Okay, so simply plug it into your calculator, but I think you should be able to solve those by hand too, in case the need ever arises. All right, so this is a division. Okay, and we could do the same thing, but in this case, we are going to subtract our exponents, right? So 6 minus 3, these are our exponents. 6 minus 3 is 10 to the third. Okay, so here's our times 10 to the third. Okay, and then we're going to, for fun, I guess we'll just do it long division. This is not a big number, so we're okay. Move our decimal places. 25 goes into 86 3 times. Subtract. Add a 0. 100. And 4. So we get 3.44. Okay, so 3.44 times 10 to the third. What are our units? Okay, so make sure you don't forget your units. We have grams and nothing cancels in centimeter cubed. So we simply, we do grams per centimeter cubed. Okay, so that is our answer. Okay, let me show you on the calculator, because it is super important. For denominators, they do need to be in parentheses, okay? So we've got 8.6, okay, raised to the 6th, okay, divided by, now parentheses on your denominator, because otherwise it's not going to take into account your exponent. Okay, so now we've got 2.5, and then we've got times 10 raised to the third. Third. Okay, end parentheses equals. Okay, our answer is 3,440. Kind of the rule is if it's a 10 to the third or greater, you'd put it in scientific notation. So our answer then would be the same that we have on our notes already, which is 3.44 times 10 to the third grams per centimeter cubed. All right, moving along. Okay, so here's addition and subtraction. Again, you simply plug in your calculator, but if it seems weird to you, okay, you're going to be able to add and subtract if you need to. Always nice to check your work. Maybe you forgot your calculator, whatever. But I'll show you how to do it if you have to do it by hand. Some of you are like, okay, oh brother, I've already done this before in 6th grade, and that's fine. You can move on and do these on your own, okay? But if you do need help, I'm going to work these out for you the first time. Okay, so we're adding these, and what we want to do is make sure that our exponents are the same, okay? And in this case, they are not. So I'm going to go ahead and make, I'll go ahead and make 10 to the negative 8, 10 to the negative 7, so I'm making it larger. If I make that larger, I'm making this smaller. All right, so I've got 1.560 times 10 to the negative 7. Oh, I don't need that 0, sorry. Not yet anyways. Okay, and then I've got 0.2, because I'm making this smaller. To make it smaller, I've got to move it to the left, right? So I'm making it smaller, so I've got 0.245 times, I'm making my exponent bigger, right? So times 10 to the negative 7. Okay, and then I'm going to put this placeholding 0 right here, so it's easy. 5 and 0 is 5. 6 and 4 is 10. 8. 1.805 times, simply bring down your exponents. They are the same. Your units are in grams. Okay, box your answer. Okay, now simply plug into your calculator. Once again, we got 1.56 times 10 to the power of negative 7 plus 2.45 raised to the power, or times 10 raised to the power of negative 8. Notice I did not need to change my exponents to be the same. I'm just simply plugging in what the problem says. I get a really small number. I can count the zeros out, but we already know that our answer is 1.805 times 10 to the negative 7 grams. All right, moving on. Again, you can pause me right now to make sure you can plug these in okay. I'm going to simply just give you the answers, and if there's any questions on that, you guys can ask me during class the next time I see you, or come and see me during office hours, which we will have Tuesday through Friday. All right, so, okay, so the first answer then is 1.56 times 10 to the negative 3 centimeters squared. Don't forget your units. Okay, and then we've got B as 7,083 grams. Remember, the rule is kind of 10 to the third or greater. I'm pretty lenient on this, though. I would not mark down if you, gave me the first or the second. Okay, subtraction, so we just simply write down the units. Okay, letter C. Now this comes out to be 320. So no need to put it in scientific notation because there's only, 2 places. But don't disregard your units. So centimeter, this is division. So centimeter goes into centimeters squared 1 time. So we have 320 centimeters. All right, moving on. Our subtraction here. Okay, so we subtract those out. It's the same way I did the addition if you're doing it by hand. So the answer is 8.3967 times 10 to the negative 2 grams. Okay, we're gonna get into sig figs a little bit just to talk about the basic rules, and then I'm going to stop for today. Okay, so this all has to do with precision, okay? So take a look at these are graduated cylinders, okay? I'll show you all the lab equipment when we get back to class, because it's much easier to see it and touch it and feel it to know exactly the different pieces of glassware. But anyways, this is a graduated cylinder, and notice the tick marks just read 1, 2, 3, 4, 5. Now on graduated cylinder B, you can see that there's tick marks going up to 1, tick marks going up to 2, to 3, to 4, to 5. Okay, so this one is going to be more precise, okay? Because there's more measurements, okay? So if I were to buy this online, Flynn Scientific, this graduated cylinder B would be more expensive than graduated cylinder A. The more precise the instrument, whatever it may be, is more expensive because it just takes more time to make these. Okay, so you can see cylinder A counts by 1 mil, right? These are all, volume is milliliters with our graduated cylinders, okay? There's going to be times where, of course, we're going to convert it to liters, and I'll show you how to do that coming up here soon. But volume with our graduated cylinders are always in mils. I'm so sorry. Okay, excuse me. All right, and then of course, so that's by 1 mil, and you can see here on graduated cylinder B, it's measured by 0.1 mil. So we got 1.1 mil, 2.1 mil, whatever the measurement is. Okay, so graduated cylinder B is indeed more precise. Okay, and you're more confident. It's just more precise. All right. So here's an example of a graduated cylinder. And, okay, so this is a graduated cylinder that has 50 mils, right? You can measure up to 50 mils. Now, we're going to have a separate measurement lecture. I'm hoping we're back in class for that, but we shall see. But for now, take a look at this graduated cylinder, okay? And this is the meniscus, okay? We'll talk about that when you can actually see it. Meniscus. Okay. Now, the bottom of that curved line is where you read it from. Okay. The bottom of the curved line. So we'd be reading it right there. Okay. And we'll talk about that, the reason for that as well when we get to measurements. Okay, but every measurement has some degree of uncertainty, okay? But we are absolutely sure. We're going to look at the tick marks, right? And so we've got 40, 41, 42, 43. We are absolutely certain that there's 43 mils of whatever substance there is in this graduated cylinder, okay? So there's 43 mils. Now, when we measure in the lab, we always include the degree of uncertainty. And how do we include that? By using a sig fig. Now the sig fig is what we're not sure about, okay? So we are not sure about this digit right here, okay, the 0, okay? Now it could be that I look at this graduated cylinder and I think it looks like 43.1, okay? And someone else looks at it and they're like, oh no, it's definitely 43.0. Okay, it's a little bit easier to look at this picture on my slide to know that it's 43.0, but this is our guess, okay? The uncertainty is our guess, okay? So it can vary from student to student, okay? But you do have a level of certainty, and that is what's measured on the tick lines. So we see 40, 41, 42, 43, so we know with absolute certainty that it's 43 mils because that's the measurement using the tick lines. We always go one digit past the measurement of uncertainty, of the tick marks. So that's why it's 43 point something. I'm not going to ask you for the plus or minus, so you can disregard that for now. All right, moving on. Okay, so which numbers are significant? Okay, all non-zero numbers are significant. Okay, you have to memorize these rules. You'll find that students get really annoyed by sig figs because I always say, how many points did you leave on the table? And it's typically due to sig figs, okay? Most students get the units down pretty quickly, but the sig figs is something that haunts you for the whole entire year. Okay, some zeros are significant and some are not. How do you know? Here's the rules that I want you to memorize. All right, so leading zeros. So that's in front of your number, okay? So these are your leading zeros, okay? And it doesn't matter if there's a decimal or not, okay? So regardless, leading zeros are in front of your non-zero numbers. They're never, ever, ever significant, okay? Therefore, there are 3 sig figs. 1, 2, 3. Any non-zero number is significant, right? So we've got 3 of them right here. Those are the significant numbers, okay? Moving on. That's our first rule. Okay, second rule. So the first rule is pretty easy. The second rule is really easy too. Captive zero. So they're the ones in between, regardless of whether or not there is a decimal place. So here's our captive zeros. They're sandwiched. They're always significant because they're sandwiched between non-zero numbers. Therefore, there's 1, 2, 3, 4, 5. So there's 5 sig figs and 16.007. So anything sandwiched, oh, I should get rid of that. Anything sandwiched is significant. Okay? Any zeros that are sandwiched are significant, and they're sandwiched between non-zero numbers, okay, which are 1 through 9. Okay, so those 2 rules are pretty simple to remember. The third one is kind of a tricky one, and students often forget this. Okay, so this is trailing zeros. So trailing zeros at the end of a number, okay? So we've got our trailing zeros here. We've got 100 meters. Okay, these zeros right here are trailing, 1, 0, 0. Okay, so it's not significant. However, if there is a decimal place, the zeros are significant. Okay, so 1, 0, 0 with a decimal place, that means it's significant, and there's 3 sig figs. Okay, trailing zeros. If there's no decimal place, they are not significant. If there is a decimal, it is significant. Okay, so let me give you this one because this is something. Okay, so these 2 zeros are trailing. Okay, and there is a decimal place. So there are 3 sig figs here as well. Okay, 3 sig figs here as well. Okay, it doesn't have to be at the end of the trailing zeros. It could be wherever in the problem. Those zeros are significant. All right, I think that's where we're going to end. Oh, actually, you know what? We'll do this practice really quick, and then that will be our last slide today. So go ahead and try to do this on your own, and then we can just double check your answers with mine. All right, so we've got, okay, so that was like the sample, the 10.0. So we've got our trailing zeros. There's a decimal place, so there are 3. Okay, here, these are leading zeros. We don't care that there's a decimal. Any leading zeros are not significant. Therefore, there's only 1. Okay, here we've got both leading and trailing, right? Leading zeros are never significant. Trailing zeros are significant. So there are 4. Okay, now we've got a number here, 40,300. Okay, so think about this one. Now, this is sandwiched, right? This is held captive, so of course that's going to be significant. There's trailing zeros. These are the trailing zeros, but there's no decimal. So how many sig figs are there? 3. So these 3 are your sig figs, okay? These 2 are not because there's no decimal. Okay, whenever you see scientific notation, this is never significant, okay? You just count whatever the coefficient is. Therefore, 5.00, there are 3 sig figs. Okay, we will continue working with sig figs for our next lecture, but it is something like you'll get really good at eventually, but it does take practice. And we'll go over this next slide next time. Bye.